These are your 4-7 notes on inverse linear functions. We are going to look at what an inverse is, and then we're going to look at different forms of inverses as ordered pairs, as a graph, and then as an equation. So we'll be able to find the inverse of a relation or a function in all those different forms. So first, let's just talk about what an inverse relation is. It's a set of ordered pairs by obtaining the exchange of the x coordinate with the y coordinate of every ordered pair of the relation. So you're just switching the order in which you have the x and the y coordinates. So the domain of the relation, which is your x coordinate, becomes the range of the inverse, which is your y coordinate. And the range of the relation, the original problem, your y value of the original problem, becomes the domain of your inverse. So if you have the relation is x comma y for the inverse, it will become the ordered pair y comma x. And that's really, in the most basic terms, what an inverse is. So if you look at the first example here, we have a set of ordered pairs. It is true for all of the ordered pairs. So instead of having -3, 26, we'll have 26, -3. You switch the order. Instead of 2, 11, we'll have 11, 2, -1 and 6, and 20 and -1. Notice I maintain the signs. It's just the x becomes the y and the y becomes the x. So I showed you in a set of ordered pairs. Here's a table format. Same concept. We can write it as a set. And so these are just ordered pairs. That's the ordered pair -4, 3 becomes -3, -4. -2, 0 becomes 0, -2. 1 and 4.5 becomes 4.5, 1. And 5 and 10.5 becomes 10.5 and 5. So just switch the x and the y values when given a set of ordered pairs. When given a graph, if you remember, a graph is an infinite set of ordered pairs. So we have to switch all of these ordered pairs. So if we just pick a couple and write down what they are, we can write down the reverse ordered pair. So let's get 3. I think 3 is a good way to figure out what ordered pairs we have. So you look at the original line. Remember, there's an infinite supply of ordered pairs here. So I just need a couple to guide me in graphing. Now if you look, this is my x-axis, this is my y-axis, just to kind of know what ordered pairs I'm dealing with. So I like this ordered pair here is the ordered pair 1, 2. And I like this ordered pair here, which is -1, 0. And let's just go with this ordered pair right here. And that is the ordered pair 1, 2, 3, 1, 2, 3, 4. So 3, 4. So I have my 3 ordered pairs, -1, 0, 1, 2, 3, 4. And then I'm going to change them into the inverse. So 0, -1 is there. 1, 2 becomes 2, 1, which is here. And 3, 4 becomes 4, 3. So 4, 1, 2, 3, 4, 1, 2, 3. And there's my other equation. So you connect and extend. You just need 3 of them. You could use more if you wanted. And then the other graph here, let's do the same thing. So I got to find ordered pairs. So you just got to look on the line to find good spots. So this is a good spot. That's -1, +1. This looks like a good spot. That's 2, 0. And even this one right here. That's where the arrowhead's going. Looks like it's 1, 2, 3, 4, 5, -1. All right. And so when I switch those, I got -1, 1, 2, 0, and 5, -1. So when I switch them, -1, 1 becomes 1, -1. So that's 1 to the right, down 1. 2, 0 becomes 0, 2. So that's up 2 on the y-axis. And 5, -1 becomes -1, +5. 1, 2, 3, 4, 5 up here. So those all line up nicely. If they don't line up nicely, either you graphed the wrong point or maybe it wasn't a point on the line. Now, If you can see in number 3, the two lines are parallel. That can happen. And in number 4, they intersect. It just depends on what the inverse looks like. I will tell you, in both results, the parent function y equals x, which is also called the identity, will be a line of symmetry. So that's this 45-degree right down the middle. If you make a dotted line right down the middle, 1, 1, -1, -1, -2, -2, 0, 0. If I fold it on that green line, my inverse function and my original relation should match up symmetrically. Excellent way to check if you did it right. Same thing here, 45 degrees going right through 0, 0. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, all the way through the end. If I folded on that green line, that X would mark the spot, and it would be symmetrical. So it's a nice way to see if you're doing it right. So I showed you with ordered pairs, I showed you with a graph, and now we got to actually do the actual function, right, the inverse of an equation. So just really quick, some terminology. An inverse function, a linear function has an inverse function. It's read as the inverse of f of x, and the symbol of it is just f to the -1 of x. When we raise something to the -1 power, it flips it. So like 2 to the -1 power actually makes the reciprocal, the inverse of it, 1/2. So we use -1 as an exponent as a symbol for inverse, because 1/2 is the inverse of 2. So the inverse of f of x can be written as f -1 of x, and it's just read the inverse of f of x. Now, just because the original function is a function, doesn't mean that the inverse will be a function. We just call that an inverse relation. And this is that whole symmetry I was just telling you about. The graphs of the function and its inverse are symmetrical with the line y equals x, which is known as the identity function. So if you're given an equation, they're going to give an equation, f of x equals something. First thing we want to do is get rid of the f of x so it's easier to see the x and the y. F of x is just fancy for y, so you just replace the y for f of x. Then you interchange x and y. You pick up the x, pick up the y, and move them. All signs, numbers, symbols all stay in the right spot. The only thing that moves are the x and the y. And then you solve for the new equation for y, and you can replace the y with f -1 of x just to make it fancy. So the very first step is to get rid of the fancy f of x. The very last step is to bring it back in there, make it fancy mathematical. So let's look at these examples. Of number 5 here, it says f of x is equal to -3x plus 27. First step that we just had, and you can always refer to these when you're doing your homework. First step says replace the f of x with a y. So y equals -3x plus 27. So it's just changing the f of x to a y value. Second step says to flip-flop, switch x and y. So that -3 is going to stay there. Everything else stays in place. So this just becomes x equals -3y plus 27. And what we just did is we made it now in terms of x equals, but when we write equations, we always want them in terms of y equals. So we got to solve for our new y. We want to get this new y by itself. So right now it's being multiplied by -3 and then adding 27. So we're going to subtract 27 first. We're going to use the order of operations to get y by itself. So x minus 27 is equal to -3y. Now to undo the -3 multiplication, I'm going to divide by -3. I can actually divide both of these by -3. Since -3 goes into -27, I'm going to do that. So when I divide 1x by -3, I get -1/3 x. When I divide -27 by -3, I get a +9. And then that's my y value. So the last thing I'm going to do is replace that y with a fancy f -1 of x. And I'm going to switch the order. So f -1 of x is equal to -1/3 x plus 9. So I replaced the y value with that crazy thing here, and I just switched the order. There you have it. That's the inverse. The second example here, let's do the same thing. So we're going to start off, step 1, replace f of x with y so that we actually have an x and a y to interchange. Second step is to interchange x and y. X is equal to 3/4 y minus 8. And now solve for the new y. So new y is being multiplied by 3/4 and then subtract 8. So we need to take care of the plus 8 first. X plus 8 equals 3/4 y. I can do this a couple different ways, but the way I'm going to choose, I'm going to multiply both sides by 4 to get rid of the 4. Multiply this whole side by 4, which I can distribute. 4x plus 32 is equal to 3y. And then when I divide by 3, I have to decide, do I want to actually divide by 3 or I can leave it underneath? In the last example, I divided each term by -3 over here because 3 went into 27 evenly. Over here, though, it doesn't really make sense. I'll just have 2 ugly fractions, so why not just have 1 ugly fraction? It doesn't matter. If you wanted to divide each of these terms separately by 3, that would be an okay answer as well. So y equals, you can call that 4/3 x plus 32/3, or you can leave it like this, either one, and then in the end, we just got to get rid of that y. F -1, the inverse f of x is equal to 4/3 x plus 32/3. And there's our inverse function. If we were to graph our inverse and the original function on the coordinate plane, they should be symmetrical along that 45 identity function. Lesson summary, I want you to write the inverse of that function, and then I want you to get, well, actually both. So one I gave you the ordered pairs, and then the other one I want the inverse of that equation. Good luck.